Welcome to this tutorial series on the Interplanetary Linked Data Project, or IPLD for short. In this video, we're going to go through a quick overview of what happens when we add a file to IPFS and how that ties CIDs, DAGs, and UnixFS together. I will show visual examples first explaining the process, and then show you some handy UI tools to experience these topics firsthand. This video isn't an overview on all those topics, so if you want to learn more, I suggest you check out this free learning site made by Protocol Labs at curriculum.pl-launchpad.io. The first thing we will look at is how data is prepared for storing or sharing when you add files or directories into IPFS. There are three main processes a file has to go through before a unique content identifier, aka a CID, can be returned to the user. So in the first stage of these processes, each file in a directory gets singled out, and then they get broken down to their individual blocks of data in a process called chunking. Then, after each file has been broken down into these chunks, they go through a process called hashing for a CID to be assigned to each block. Finally, links have to be created to tie all the blocks together to form the directed acyclic graph, or DAG for short. And this DAG is going to be in the same shape of the original directory or file. This hierarchy of blocks forms from creating metadata blocks, which contain links to reference the blocks underneath. After this DAG has been created, that's when the root CID gets returned to the user. Each of these three processes live within a subsystem of IPFS called UnixFS, and it is important to note that UnixFS is specific to the Go and JavaScript implementations of IPFS, so other implementations may have different methods of doing these processes. So, as you have seen, the first stage is the preparation phase that every file has to go through. The second and third stages are where CIDs meet DAGs. These two phases continue to alternate between each other until a single point has been reached. In IPFS, you can't build a DAG without CIDs, and data that CIDs are attached to just wouldn't make any sense without DAGs. Now, as a visual analogy of this, I have this picture del Monumento a la Revolución that's in Mexico City. You can imagine that if I wanted to add this photo into IPFS, UnixFS will break down the photo into 9 puzzle pieces, and each of the pieces will be hashed and thus assigned a CID. But they are in essence all jumbled up and there is no coherent structure to them. That is, until the forming phase, where UnixFS will start connecting the pieces together in the order that forms the correct picture. Of course, in reality, as previously mentioned, the form in which the pieces are connected are in the structure of a DAG. Now you might be wondering, but where does IPLD tie into all of this? Well, the core of IPLD's importance is centered around its data formatting standards. These standards are what UnixFS uses to create the metadata blocks, thus allowing us to find the correct ordering and location of the data. You can imagine it as having numbers placed on a puzzle board telling you exactly where each piece goes, and pieces have to be in this exact order or else you won't have the same image. Now we can use some online tools to get first-hand experience and see how graphs look drawn out and under the hood. The first tool is a DAG Visualizer, which we can find at dag.ipfs.tech. So the first thing it will ask us to do is to upload a file. So we will add in the photo of El Monumento. Now, by default, the app will render the graph with a block size of 512 bytes, but that will make our graph look huge. So we can fix this by changing the block size to be 16 kilobytes. Now, we can easily see that the green square blocks at the bottom are the raw data of the photo, aka the puzzle pieces. The dark blue circles in the middle are the metadata blocks, and the highest one is the root CID. We can also see here that each block has its own CID, a reference to its size in bytes, and how many other blocks it links to. Now, if anything happens to the layout of the graph, then the root CID will change. This is in essence like changing the order and location of the puzzle pieces. You can almost think of the root CID as like an instruction set that IPFS needs to follow so to assemble the puzzle properly. If we click on the CID link, it will actually show us those instructions. With version 0 CIDs, there are some instructions that are implied, but with version 1 CIDs, everything has to be explicitly written out. We have things here like multi-base, multi-codec, and multi-hash, which are all defined within a library called multiformats. Multiformats is part of the IPLD project as well, since IPLD is all about having these standardizations. Lastly, to see how this graph would look using the default options in IPFS, we will change the block size to be 256 kilobytes. The second handy tool is the IPFS Desktop App, which we can install from docs.ipfs.tech/install/ipfs-desktop. We'll just scroll down to find our operating system and just follow the instructions. Once we have the app, we'll open it up, and from here we can add our photo to IPFS. The handy thing about this app is that we can see the native IPLD data formats called codecs. Each codec will have a CID section, size, link, and data section. Different codecs will transform these fields to look differently, but they basically all say the same thing. Underneath, we have the ordering of the blocks that the root CID link to. And if we click on one, then we can see the default block size used by IPFS is in fact 256 kilobytes. In this collapsible section, we can see the low-level details regarding the file that IPLD defines. Not only that, but we can also see the data that pertains to this specific block. If we go back one page, we can see the same DAG structure as where we left off in the DAG Visualizer. But here, all the data and metadata blocks look the same. Finally, we have a condensed version of all the details regarding the CID on the top right-hand side. Altogether, this gives us a complete picture of how our file or directory looks like under the hood when added to IPFS. And with that, we have arrived at the end of the video. So to summarize, we learned that IPLD standardizes the technical file details for anything being added to IPFS and how UnixFS uses that data to form a DAG. I encourage you to try out the IPFS Desktop App and the DAG Visualizer to better your own understanding of the process. Thanks for watching, and hasta luego!